Assalamu alaikum wa rahmatullahi wa barakatuh. Dear student of third secondary, we are going to solve Alostaz book. We will start with questions of chapter 1. Okay, at first we will illustrate that we have our book contains more questions for the new curriculum and we will discuss all of them together. We will start with the chapter 1 transition element and we have from the beginning of the chapter till the general properties of 3D element. Okay, let's start with questions from the book. We have booklet 1 today from page 1 to page 3. Okay, let's start. Question number 1 says that the number of transition elements in the fourth and fifth horizontal periods is what comparing to the number of elements in the sixth period. If we make a comparing between them, okay, we have choices here: greater than or more than, less than, equal to, or double. Okay, if we make a comparing between them, we will find that in the elements of the sixth period we have a great number of elements. We have 32 elements, but the number of transition element in the fourth and fifth period only we have 18 elements. So if we make a comparing between them, as we say, in fifth and fourth we have less number, 18, but in sixth period we have 32 elements. So if we make a comparing between them, if we start with fourth and fifth, we are going to say they are less than. If we start with sixth period or sixth period, we have the less than. So we start with the less one in number. So we have the number of transition element be less than. So the right answer will be letter B. Okay, I think it's simple and easy question. Let's going to question 2. Question number 2 says that inner transition elements are located in the. Okay, we have choices here. First two periods in the long periodic table, last two periods in the long periodic table, right, left and center of the long periodic table, and the last one here, right and left of the long periodic table. If we make a comparison between our questions, we said that when we looking at the periodic table, we have at both sides on the left and right we have what? We have the representative element, but in the middle we have the transition element, and below the table what is the participation of them? The part in the middle we called them inner transition element. Okay, so if we discussing them, the inner transition element are located in the 6 and 7 horizontal periods. So the inner transition element or the last of them, we have the first transition element, second and third we have the last one, or we call them 6 and 7 horizontal periods, so we call them the inner transition element. So the right answer here will be letter B, last two periods in the long periodic table. It means that they are the last one that containing the inner transition element. Okay, let's going to question 3. Question 3 says that the first transition element in the periodic table exceeds potassium by. Okay, we have potassium as an element that have number 19. Okay, let's discussing our choices. We have 1, 2, 3, and 4 electrons. Okay, if we discussing, we know that potassium atomic number is 19, but we have the first element in the transition elements that starts with what? That starts with the atomic number 21. So the difference between them, 21 minus 19, giving 2 electrons. So the right answer here will be also letter B. Okay, I think it's easy question, but we need to know the transition element starts with the atomic number 21, the first one in the transition element as well. Okay, this is question number 3. Let's going to question 4. Question 4 says that the vertical group that doesn't contain transition element in the periodic table. Okay, we have choices here, 3b and group 8 with V and 3i behind, group 3a, and here we have IVB is group, what is group 4. Okay, so we have choices here. We said before, when we classifying the parts of the periodic table, we have the two sides at the right and the left. We have all the representative element, but and they take the letter 1a, 2a from the left, and from the right we have 3a, 4a, 5a, 6a, 7a, and group 0. They are on the post two sides, so we call them representative element. But in the middle we have the transition element. They take the letter b in the middle. We have starting from group 1b, 2b, 3b, 4b, 5b, 6b, 7b, and group 8, including the three columns together, including the middle of the table. And below the table we have the F block containing lanthanide and actinide below the table. So we have in the middle we have the transition element that they take the letter B and they take the Latin number. We have number 1, 1b, okay, or IB, and group 11, 12 we have 2b or 2IB, and 3 we have 3IB, and 4IVB here in our choices. Group 5 that take the letter VB, and 6 VIB, 7 V2IB, and 8, 9, and 10 in one column take the letter V3I and B, or can we write V3I behind it? Okay, so we have choice A from the transition, B and D, the one that not in the transition element, that make it in the side, right side of the table, make it a representative element. We have group 3a not among the groups of transition element, so the right answer here will be letter what? Letter C. Okay, let's going to question 5. Question 5 says that the ratio between the number of groups V3I elements and 1B elements. Okay, you know, we said before in the previous questions that we have group VI3 that containing what? That containing 3 groups in one column, or we have 3 column that forming one group only, but we have here one element or one column only in group 1b element in the same horizontal period equals, we have choices here, ratio between them 1 to 1, 2 to 1, 3 to 1, and the last one 3 to 2. We said that we have in the group VI3, we said that we have 3 elements, but in one, each one containing one element. So we have group VI3 containing 3 elements per period, while 1B containing 1 element only in the period. We have elimination and take in consideration the names and letters of the groups. Please concentrate in this kind of question, okay? So the right answer will be letter C. Let's go into question 6. Question 6 says that the element 3D element whose electronic structure is 2ns power 2. Okay, we have 2 electrons only in the S here or S block, and n minus 1 D block containing n plus 2 is used in. Okay, we have the choices here. The first one, Okay, if we calculating the number, we have manufacturing the MiG fighter aircraft alloy, manufacturing of car auto springs, catalyst in Haber-Bosch method, and the leather tanning and metal plating. Okay, if we know the right answer here, okay, please try to calculate them from the electronic structure. If we calculate the atomic number here, 2n s power 2 n minus 1 dn plus 2, if we calculating this number, we find the element will be the iron. The element will be iron with the atomic number 26. We have the, if we calculating them in the transition element, n s power 2 n minus 1 d from 1 to 10, or n plus 2, we have what we have, the calculating the number will be iron with the atomic number 26. Okay, what is the uses of the iron here? We said the right answer will be the as a catalyst in Haber-Bosch method. We used iron as a catalyst in Haber-Bosch method. Okay, let's going to question 7. Says that the 3D element whose electronic structure also n s power 2 n minus 1 dn minus 3. Okay, we have here is used in, we have the uses also manufacturing of MiG fighter aircraft alloy, manufacturing of car auto springs, catalyst in Haber-Bosch method, and preparation of bronze alloy. Okay, if you calculating the structure of this element, you will find that it will be the scandium element with the atomic number 21. If we calculating it, we will find that it is a scandium with the atomic number 21. So it's used in what? You know the uses. Yes, we have the manufacturing of MiG fighter aircraft alloy. Okay, let's going to question 8. Question 8 says that skin of animals are exposed to rotting. It means become destroyed. However, chemistry solves this problem with the element. Okay, how we prevent the rotten of what? Of the skin or the leather of the animals. Okay, we have our choices here using sodium, helium, one of the groups that present in group 6b. Okay, we mean chromium, and one in the group 1b, we mean what? We mean copper. Okay, what we use to prevent this rotten? Okay, we have in the group 6b, we have what? We have chromium. We have in the group 6b, we have chromium. As I said, that it's the main use is prevent rotting of leather or leather tanning. Okay, we have the leather tanning or that prevent the rotting of what? Of the skin of animals. Okay, this is the right answer will be letter C. Okay, let's going to question 9. Question 9 says that the car spring is made from which element? That is the main in making the car spring, that make it more elastic. Okay, we have choices here: very ductile material, heat sensitive alloy, corrosion resistant material, and pure transition metal. Okay, if we want some make elastic, or we have an element that will be what? That will be vanadium alloy with steel is very hard and corrosion for the resistance, as it make it corrosion resistant alloy that makes the car springs live a long time and can resist any of the corrosion when make traveling for long distance. Okay, let's going to question 10. Question 10 says that to protect metals from corrosion, okay, they are coated with the element what? Which is resistance to interactions with atmospheric air. Okay, we have the first one of our choices, element with electronic structure ns1 n minus 1 d5, and B, ns2 n minus 1 d5. Number C, ns2 n minus 1 d1, ns2 n minus 1 d6. Okay, do you know that when we want to protect any element that we use from protection, we must have more inactive element more than the present. So we have the element that we want to coat our metals from atmosphere. That is the main behavior of chromium. Okay, as we said in the previous question, that chromium resists the action with atmospheric air or make a layer that like a blocking for the reaction with air. So we choose the element chromium, with the atomic number 24. So we have the our choices here, the that letter A in our question. So we have its structure ns1 n minus 1 d5. Okay, so it's our element what, chromium, with the atomic number 24, with the atomic number what, 24. Okay, this is the right answer for question 10. Let's going to question 11. Question 11 says that bicycle frames are made from, of or from what? We have titanium or vanadium alloys. We have alloys that are very sensitive to heat. We have pure manganese metal, and the last one, pure metals. Okay, how we can know that frames make it resist corrosion and make it what, make it very light, that make all the bicycle can be go with a little mass or little weight. Okay, if we concentrate to it, we have titanium or vanadium alloys are very hard, that can move for a long distance with very light and can resist any corrosion with what, with atmospheric air. Okay, let's going to question 12. We have our choices here, letter A, titanium or vanadium alloy. Let's going to question 12. Question 12 says that potassium permanganate is an oxidizing substance. Okay, due to what? We have our choices here. We have its oxidation state +2 is more stable, +3 oxidation state is more stable, and it's the ease of oxidation of the manganese ion when it is will be V2I here, so it will be in the group 7. Okay, all of the previous. Okay, do you think what is the right answer here? We said that potassium permanganate is an oxidizing agent, as it has one oxidation state, it will be the more stable state here, as we have in case of Mn+2 manganese here, it's more stable state that have filled with electrons. We have 3d5 electrons, so it gives high degree of stability, so it will be in the oxidation state +2. Oxidation state +2 is the more stable, so our choices is letter A. Let's going to question 13. Question 13 says that the oxidation state what is the most common in the most transition element in the fourth period. Okay, in the fourth period, the most oxidation state we have the +1, +2, +3, and +4. If we concentrate on the most of the oxidation state here, all the 3D elements in period 4 give the oxidation state +2, except two elements only. We have scandium and zinc. Okay, so the right answer here will be letter B, +2. Okay, let's going to question 14. Question 14 says that the largest number of oxidation for each 3D elements is equal to the number of vertical group of element except. Okay, we have all of them containing one element in the group, except group what? Group 8 consists of three groups collected in one group only, or containing three columns in one group. Okay, we have our choices: 3b, 7b, vi3, and 2b. Okay, I think it's question very important and repeated many times. Okay, we have the element of vi3 have the highest oxidation state will be +6, which is the less than their vertical group number. Its vertical group number here will be 8, but its oxidation state maximum will be +6. Okay, so the right answer will be letter C. Let's go to question 15. Question 15 says that aluminium, scandium, and nickel all share that in what? Okay, we have the first in our choices. They all lie in the same horizontal period. They all lie in the same vertical group. They all have the oxidation state +3. Their ionization potential breaking completely or completed energy level. Okay, if we concentrate on aluminium, scandium, and nickel, they share all of them that loses 3 electrons, so it will be have the most stable oxidation state will be 3. Okay, it's more important question, as nickel and scandium most in our transition group or in the transition elements, that its most stable will be 3 plus 3, but we have aluminium containing 13 electrons and it loses 3 electrons, and it's not from the transition element, but it is from representative element that loses 3 electron, and all of them share in they have the oxidation state +3. Okay, let's going to question 16. Question 16 says that the third ion of what is similar to the structure of krypton gas. Okay, we have here scandium, yttrium, iron, and zinc. Okay, we have the third ion. It means that it loses 3 electron, and we will be here the similar to krypton gas as it is an inactive element. Okay, if we concentrate, we will find that yttrium loses 3 electrons, and the number of remaining electrons become 36, and it will be similar to the nearest gas will be the inert gas what? Krypton. Okay, let's going to question 17. We have our choices here, letter B. Let's going to question 17. Question 17 says that to break the complete energy level in vanadium, it requires to lose what electrons to be similar to argon ion under certain conditions. Okay, if we want to break the energy level of vanadium, so it will lose what? It will lose 6 electrons. It will lose 6 electrons. So the number of remaining electrons become 17. So it will be similar to what? Similar to the argon ion. Here, under certain conditions, we convert argon as an inert gas. Is we converted it to what? To argon ion, Ar plus 1. Okay, so it will lose 6 electrons. So the right answer will be letter D. The right answer will be letter D. Please try to read the sentence slowly, that we have argon ion, not argon gas. Okay, let's going to question 18. Question 18 says that the minimum oxidation state of 3D element is that of. Okay, we have transition element at the beginning of the series, transition elements at the end of the series, transition elements in the middle of the series, and vertical elements of the group 6b. Okay, what is the minimum oxidation state of 3D elements? We have the last transition element at the end of the period, where the copper take the lowest oxidation one here will be +1. Okay, when the copper is more stable, it will be make the oxidation state +1. But sometimes it take +2, but it is the most stable and most common for the copper, and as it is metal but it is less active and resist corrosion or inactive to any condition surrounding it, so it will be its oxidation will be plus A. So the right answer here will be letter B, transition element at the end of the series. That it's our choice belongs to what? Belongs to copper with atomic number 29 and oxidation state +1. Okay, let's going to question 19. Question 19, that all elements of the following vertical groups have the oxidation state +3 except, okay, let's going to the choices. We have group 3b, 4b, 2b, and group 8, Vi3. Okay, all these elements have the oxidation state +3 except what? Do you think we have oxidation state? Zinc take the oxidation state what? The oxidation state 1 only, as the zinc present in the group 30 and or in the group 2b. In the group what? In the group 2b, or we can write 2IB. We can write 2IB or 2 as a digit 2b. Okay, let's going to the last question of our exam. We have question 20. Question 20 says that iron Fe +3, we can said it's a ferric ion, is transformed into ferrous ion Fe +2 by what? And titanium +2 converted or transformed into also titanium +4 or titanium ion by what process respectively? Okay, we have here, we wanted to convert from one stable to the less stable, and here from one less stable to the one stable. Okay, we have the first one in our choices, simple oxidation. If we want to change from one stable to one less stable, we need oxidation or reduction at first. If we concentrate, we have more stable will be iron Fe +3. If we converted it to what? With the half full 3D 5, so we need what? We need to make reduction. We need to make reduction or make hard reduction. But here we have from less stable to the more stable element, we have from Ti +2 to, as I said, from one less stable to the more stable Ti +3 or titanium +4, sorry. Titanium +4, we have the more stable as it is completely empty or no electrons in it, and we have D is stable here with 0 electrons. So if we wanted to convert from T +2 less stable to T +4 more stable, we make simple oxidation. Okay, if we convert from less stable to more stable, we have oxidation. If we convert from more stable to less stable, we make reduction. But in case of iron, we make hard reduction as it need large energy to convert from iron +3 to iron +2. But in the case of titanium, we make oxidation as we convert to from one less stable to one more stable Ti +4 or titanium ion +4. So we make simple oxidation. Okay, so the right answer here will be letter D. It's at the end of our booklet today. Okay, I hope you enjoy our question today. Thank you for joining. Okay, this is the first booklet. Please wait for the second one in our questions. I hope you enjoy it. Thank you and goodbye.